A ship the length of more than one football field just rose straight out of the ocean and stood there like it was standing on invisible legs. No wobble, no drift. Waves crashed below it, and it did not move even 1 centimeter. This is not a movie trick. It is not a special effect. It is a real vessel called the Gangfong 5, and it was built to solve a problem that had stopped the entire global offshore wind industry cold. A problem that engineers in Europe and the United States had quietly accepted as a permanent limit on what was physically possible. That limit is about to be explained, and once you understand it, what China built to break through it will make a lot more sense. The crane on this ship can hoist 1,800 tons, nearly 200 meters above the water. The turbine blades it installs are longer than a football field. The towers it lifts into position are as tall as a 60-story building. And by the end of this video, you will understand not just how China built this machine, but why the rest of the world is only now starting to realize what that actually means for the global energy race. But first, the wall. Because this story begins not with a ship, but with a ceiling nobody wanted to touch. For years, wind turbine companies kept building bigger and bigger machines. The logic was simple, and the economics were hard to argue with. Bigger turbines make more electricity from fewer parts. Fewer parts mean fewer ships, fewer cranes, and fewer trips out to sea. Every increase in turbine size made the whole operation cheaper and more efficient. So size was always the goal. But there was a wall nobody could get past, and that wall had nothing to do with the turbines themselves. It had everything to do with the ships trying to lift them. Once turbines passed about 18 megawatts in power, the parts became so heavy that regular crane ships could not lift them without creating a genuinely dangerous situation. Picture a crane arm swinging out over the side of a ship floating on open water. The moment a load weighing several hundred tons swings out to one side, the ship's center of balance shifts hard in that direction. A small wave at exactly the wrong moment can turn the whole vessel into a giant seesaw. And when the load weighs hundreds of tons and the crane arm is reaching toward the sky, a seesaw is not a problem. It is a disaster. Engineers in Europe and the United States basically agreed. 18 megawatts was the safe limit. Anything bigger was treated as too risky to attempt installing at sea. Some companies spent years perfecting turbines right at that boundary instead of pushing further, because the ships available to them could not go any higher without serious danger. It became an unspoken rule across the whole offshore wind industry, almost like an invisible ceiling nobody wanted to test. Then China announced a turbine almost 50% more powerful than that limit, and the entire offshore wind industry went quiet. Here is what most people will never hear about that moment. The turbine announcement was impressive, but building a record-breaking turbine was actually the easier half of the challenge. Lifting that turbine onto a tower in the middle of the ocean, hundreds of kilometers from shore, was a completely different and far harder problem. To get past that wall, China could not simply build a slightly bigger crane ship and call it a day. Engineers had to rethink the entire vessel from the bottom up, and the answer they arrived at produced one of the strangest-looking ships ever built, and one of the most capable machines operating anywhere on the ocean today. The vessel is called the Gangfong 5. It was delivered in August 2024 in the city of Qingdao. At first glance, it does not look dramatically different from any other large industrial ship. It is 135 meters long and 50 meters wide, roughly the footprint of a city block with a massive crane mounted on its deck. But its real capability is completely invisible until it reaches its work site. Hidden along its sides are 4 giant steel legs. When the ship arrives at a location where a turbine needs to be installed, those legs extend downward, punching straight through the water toward the seafloor below. Once they make contact with solid ground, hydraulic systems begin pushing the entire ship upward. The hull rises slowly out of the water, like an elevator moving up 4 vertical columns, until the whole vessel is sitting above the surface with open water beneath it. And then something remarkable happens. The ship stops being a ship. Waves can roll right underneath the hull, and it will not tilt, drift, or rock even slightly, no matter how rough the sea gets around it. Engineers call this becoming a fixed platform. In plain terms, what just happened is that a 27,000-ton ship turned itself into a temporary island standing in the middle of the ocean. Most people who see footage of this for the first time assume it has to be a camera trick. A ship that size simply is not supposed to stand still on four thin legs while the sea churns underneath it. But it does, every time. This matters more than it might seem. Here is the detail that changes everything. A crane arm reaching 200 meters into the air is not a rigid structure. Even a small amount of movement at the base, a few centimeters of sway at deck level, translates into meters of unpredictable swing at the very top. You cannot precisely position a load weighing hundreds of tons when the platform underneath the crane is moving with every passing wave. By lifting itself completely out of the water, the Gangfong 5 removes the ocean from the equation entirely. The platform is now as stable as solid ground, and the crane can do its job with the kind of precision that the most powerful wind turbines in the world demand. But here is the part nobody talks about when they cover this ship. Getting those four legs safely onto the seafloor is not as simple as it sounds. And the hidden danger waiting under the waves is something that has caused real accidents on similar vessels around the world. The seafloor looks dependable from the surface, but underneath that blue water, it is far less predictable than anyone standing on land would assume. Sometimes the seafloor has only a thin crust of hard-packed sand sitting on top of soft mud, loose silt, or pockets of water trapped underground that no surface scan can detect. When a heavy ship leg presses down expecting solid ground and instead finds one of these weak spots, the leg can punch straight through the crust and sink several meters in just a few seconds. Engineers in the offshore industry have a specific name for this danger. They call it leg punch-through, and it has caused documented accidents on support ships in multiple countries. In some of these cases, one leg sinking unevenly created a dangerous tilt that forced emergency crew evacuations before conditions became worse. This is the kind of failure that turns a routine construction job into a catastrophe within moments. No warning, no slow escalation. 1 second the ship is stable. The next it is tilting at an angle that puts the entire crew and the load overhead at serious risk. The Gangfong 5 was designed from the very beginning to avoid this entirely. Before the ship ever lowers its legs at a new site, a team of geologists scans the seafloor using sound wave technology and drills small test holes directly into the seabed. This process tells engineers exactly what kind of ground is hiding beneath the surface, long before the ship commits to standing on it. Then, as the legs actually begin lowering toward the bottom, an onboard computer system monitors the pressure building under each individual leg in real time. If one leg senses it is sinking faster or deeper than the other three, hydraulic pumps instantly adjust pressure to keep the entire platform perfectly level. It works almost like the ship has 4 robotic feet, each one constantly checking its footing, silently correcting itself before a human would even notice anything was wrong. So leg punch-through is solved. The platform is stable. The ocean is below. Now comes the part that should genuinely be hard to believe until you see the numbers. The turbine this ship installs was built by a Chinese company called Dongfang Electric. Its measurements are honestly difficult to picture clearly. The hub of the turbine, the central point where the 3 blades connect, sits 185 meters above the surface of the water. That is taller than most skyscrapers that people walk past every single day. The 3 blades together sweep out a circle 310 meters wide, large enough to cover roughly 10 football fields laid side by side. One turbine built to these dimensions can generate around 100 million kilowatt-hours of electricity every single year. That is enough to power approximately 55,000 homes, while saving about 30,000 tons of coal that would otherwise need to be burned. One machine, one location, one spinning rotor. To put that in perspective, just one of these turbines does the work that used to require building and maintaining a dozen smaller machines. Fewer foundations drilled into the seafloor, fewer ships making the long trip out, fewer installation crews working in dangerous open ocean conditions. The scale advantage is not marginal. It is transformational. And it is exactly why engineers were so determined to push past the 18 megawatt barrier in the first place. But to install the generator unit at the very top of that 185-meter tower, the crane has to hold nearly 1,800 tons of steel, suspended almost 200 meters above open water. And that is where the engineering gets genuinely complicated, in ways most people never consider. Problem 1 is wind. At 200 meters above the water surface, even a gust that would barely register at ground level creates enormous lateral force, pushing against the crane arm and the suspended load. The forces involved at that height are far larger than intuition suggests, and they change constantly as wind direction and speed shift throughout the day. Problem 2 is more surprising. Sunlight. When direct sunlight hits one side of a tall steel tower more intensely than the other, the metal expands unevenly. The warmer side grows slightly longer than the cooler side, and because the tower is hundreds of meters tall, even a small difference in expansion across the structure can cause the very top of the tower to lean off its intended position by several centimeters. In real offshore construction projects around the world, this exact problem has forced entire teams to pause all work and wait for nightfall, allowing the metal to cool down and straighten back into proper alignment before the installation could continue. On the Gangfong 5, onboard computers track sunlight intensity, surrounding temperature, and wind speed constantly throughout the day, adjusting the crane's aim and alignment in real time so these invisible thermal shifts do not turn into expensive delays. But there is still one more problem that would logically make this entire operation impossible. And it has nothing to do with the wind or the sun. When a crane swings a load weighing hundreds of tons to one side of a ship, even a ship that has lifted itself out of the water and turned into a temporary island, the physics of that weight shift should cause the whole platform to tilt in the direction the load is moving. The same basic way a small rowboat tips, when someone leans too far over one edge. Here is what China built to prevent that from happening. Hidden deep inside the Gangfong 5's hull are large tanks that can be filled with seawater or emptied of it within seconds. The instant the crane shifts a heavy load to one side of the deck, powerful pumps move hundreds of tons of seawater to the opposite side of the ship, balancing the weight distribution before the tilt can even begin to develop. The correction happens automatically and continuously throughout the entire lifting process. The platform stays perfectly level no matter which direction the crane is pointing at any given moment. But here is the detail that makes this genuinely impressive. The crane can swing a load weighing hundreds of tons in just a few seconds. That means the ballast system cannot wait to react after a tilt starts. It has to act before the tilt happens. Engineers solved this by having the system read the crane's planned movement sequence and preemptively redistribute the seawater, predicting the imbalance before it exists rather than correcting it after the fact. That is not just clever engineering. That is a completely different way of thinking about stability. And all of this, the leg pressure monitoring, the thermal tracking, the predictive ballast correction, produces more sensor data every single second than any human engineering team could possibly process by hand. Which is exactly why this ship runs on something most ordinary cargo vessels do not have. The Gangfong 5 runs what engineers call an intelligent control platform. It is not a navigation system. It is not a crane controller. It is a single coordinated brain that manages the ballast tanks, the ship's positioning, and the crane operations all together as one unified system, reading real-world conditions in real time and adjusting every connected system simultaneously. The platform constantly reads variables most ships never track at all: water density, wind strength and direction, wave patterns, crane load distribution, leg pressure readings from all 4 contact points with the seafloor. It processes all of it continuously and adjusts automatically, cutting overall fuel consumption by around 20%. Compared to similar ships that operate without this level of automation. On a project where the ship may stay at sea for extended periods moving between multiple turbine installation sites, that fuel saving is not a minor convenience. It is a significant operational advantage. But here is the thing that should genuinely make you think. What happens if the computer system running all of this makes a critical error during a precision lifting operation? When 1,800 tons of equipment is suspended 200 meters above open water, a software failure at the wrong moment is not an inconvenience. It is a catastrophe. China's engineers anticipated this. The answer was triple redundancy. The Gangfong 5 runs 3 completely separate positioning systems simultaneously. China's own Beidou satellite navigation network operates alongside GPS and laser-based distance sensors. If any one of those 3 systems experiences an error, the other 2 instantly take over without any interruption to the operation. No pause, no delay, no human action required. The navigation and crane control computers also operate on a closed internal network that never connects to the public internet at any point, which means external hacking is essentially impossible by the fundamental design of the system itself. Not by a firewall that can be bypassed, but by a physical separation that cannot be bridged remotely. And if everything else somehow failed despite all of these safeguards, the captain standing on the bridge can turn a single physical key and instantly shut down all automation, switching the entire ship over to manual hydraulic control within seconds. The machine is intelligent, but a human can always take it back. This kind of layered backup thinking is standard in aircraft and spacecraft engineering, industries where a single point of failure cannot be allowed to bring down the entire operation. Seeing it applied to an offshore crane vessel is a sign of how seriously China has treated this project. Not as a construction ship, but as critical infrastructure that cannot fail. But even with all of this technology working together perfectly, there is one opponent that pushes the entire system to its absolute limit. One force that has destroyed offshore wind equipment around the world and continues to represent the single greatest threat to anything operating in the South China Sea: a super typhoon. The South China Sea is home to some of the most powerful and unpredictable storms found anywhere on the planet. And the offshore wind farms being built in this region have been badly damaged by these storms in the past. During Typhoon Yagi in September 2024, just weeks after the Gangfong 5 was delivered, extremely powerful winds caused serious damage to older wind turbines throughout the region. These storms can snap steel towers, tear blades apart, shut down entire wind farms for months while repair crews wait for calm enough conditions to safely reach the damaged equipment. When a typhoon begins approaching a turbine that was installed by the Gangfong 5, an automatic safety sequence kicks into action without needing any human input. The turbine's 3 massive blades rotate so they face edge first, directly into the oncoming wind. Think about what that means physically. Instead of presenting the full flat face of each blade to the incoming storm, which would be like holding a wall up against hurricane-force winds, the system rotates every blade so only the thin edge faces the wind. The same principle as turning a flag sideways so it catches far less resistance. This single adjustment dramatically reduces the pressure being placed on the entire structure during the most violent part of the storm. Meanwhile, the ship itself uses its hydraulic legs to lift its hull even higher above the rising water surface, allowing the largest and most dangerous waves to pass harmlessly underneath the deck instead of slamming directly into the hull and causing structural damage. A turbine that automatically protects itself. A ship that automatically lifts itself clear of the worst danger. 2 systems acting together without a single human command during conditions that would make manual intervention impossible anyway. The result is a combination that can survive storms that would have completely destroyed equipment built just a few years earlier. And once the storm finally clears and conditions return to normal, those same automated systems bring everything quietly back online. The turbine starts spinning again almost immediately. Clean power flows back into the grid. No days of manual inspection. No repair crews waiting for weather windows. No extended outages. Now step back and look at everything together. A ship that turns itself into an island by standing on 4 robotic legs that constantly monitor their own footing. A crane that tracks sunlight and preemptively balances the ship before a tilt can even start. A turbine so large it covers 10 football fields with every rotation and powers 55,000 homes from a single structure. A computer brain with 3 independent positioning systems that cannot be hacked from outside. and a typhoon survival system that activates automatically and brings everything back online without human hands touching anything. While engineers in Europe and the United States were accepting 18 megawatts as the permanent limit, China built a ship that erased that limit entirely. The offshore wind industry had an invisible ceiling for years. Most of the world treated it as a permanent fact of engineering. China treated it as a temporary problem that had not yet been solved. They were right, and the Gangfong 5 is the proof. What part of this ship surprised you most? Drop your answer in the comments. If this kind of engineering genuinely changes how you see what is possible, hit like and subscribe, because what China is building in the ocean right now is only part of what is coming next.